The ubiquitous yet mysterious combination safe lock. It's been around for more than a century and a half. It's appeared in hundreds of movies and is likely lurking in your home or office right now. Having seen all or most of the James Bond movies, you know that the typical safe lock is operated by entering 3 or 4 combination numbers by turning a dial. Once the secret combination is entered, the safe handle can be turned to open the door. Viewed from the inside, the final turn of the dial withdraws the brass lock bolt, unblocking a heavy cam turned by the outside handle to move the door's locking bolts. Pretty simple so far, right? But how does a mechanical safe lock actually work? To answer this question, we'll need the help of a cutaway Sargent & Greenleaf Model 6730 lock, a venerable industry standard. We'll need to identify some of the internal parts to figure out how they work together to create what's essentially a mechanical puzzle that can only be solved by entering the correct combination. First is the brass lock bolt. It's the part that blocks the movement of the other stuff inside the safe door. You remember seeing this just a few seconds ago, right? Just nod yes and we'll move along. Next is something called a drive cam. A feature of the drive cam is the drive cam gate. More on this in just a few seconds. The drive cam is threaded onto the dial spindle. Let's take a look at 3 pieces by themselves. In an assembled lock, the drive cam is threaded onto the dial spindle, then locked into place by a spline key. What this means is that when the dial is turned outside the safe, the drive cam turns at exactly the same rate inside the lock. This is the lock's lever, unless you're British or Australian. In that case, it's the lock's lever. Sorry, that's just a bit of international flavor, lock geek humor. Or not. In any case, here's the lever attached by way of the lever screw to the lock bolt. And let's not overlook the lever spring. It attaches to the lock bolt at one end and the lever at the other end. It always wants to push the lever in the direction indicated by the red arrows. Note that the drive cam gate is shaped to accept the lever nose. And this is a thumb, but that's not important right now. The lever fence is a solid bar that extends perpendicular to the plane of the lever body. I know it ruins the whole aesthetic of the lever form, but it has a really important role to play in the operation of the lock. See what the fence does? It comes to rest on the edge of one or more lock wheels and prevents the lever nose from being pushed into the drive cam gate by the force of the lever spring. Speaking of wheels, there are 3 of them in this lock. Each one holds one number of the combination. So in a 3-wheel lock, we have a 3-number combination. I know you were told there would be no math, but we lied. Every lock wheel has an opening called a wheel gate. Let's take our cutaway lock for a spin. During the first rotation of the dial, only the drive cam moves. Second rotation, the number 3 wheel also begins to move. Third rotation, the number 2 wheel begins to move. And on the 4th rotation, the number 1 wheel begins to move along with all the others. Our cutaway lock is set on a combination of 55, 23, 62. Let's dial this combination and see what happens inside the lock. First, from the outside and starting anywhere the dial happens to be, we dial left or counterclockwise, stopping when the first number comes to the opening index the 4th time. We'll repeat that dialing action, this time observing the wheel action. Note that an additional wheel begins moving with each full rotation of the dial until everything is rotating in the same direction. Did you see that? When we dialed 4 times left to 55, the number 1 wheel gate lined up under the lever fence. But wait, it gets better! The next step is to dial right, stopping when 23 comes to the opening index the 3rd time. Now the wheel side view of the same dialing action. This time we moved the number 2 wheel gate under the lever fence. The number 1 wheel gate didn't move because we didn't dial enough revolutions to move the first wheel. Now we dial left, stopping when 62 comes to the index the second time. Same dialing action, inside view. You knew this was coming, didn't you? We moved the number 3 wheel gate under the lever fence, but didn't dial enough revolutions to move wheel number 2 or number 1. All the wheel gates are now lined up under the lever fence. When we turn the dial to the right, the lever spring can now push the lever nose into the drive cam gate. A little more dialing to the right, and the drive cam pulls the lever and the attached lock bolt into the case. Voila! The lock is now open. From what we learned about the mechanism, you know why it's important to turn the dial at least 4 full revolutions when locking it back up. If you said it's because 4 is the smallest composite number that's equal to the sum of its prime factors, you've been watching a totally different video. It's because you want to make sure you've moved all the wheel gates from under the lever fence. And now you're a safe lock expert. No, not really. But you know more about mechanical combination safe locks than you did 6 minutes ago. Good on you.